This first lesson for Chapter 9, Algebra 2, 9.1. This will be more of a review lesson than things that are completely new to class. So 9.1, distance and midpoint. We've used both of these formulas before, but let's take a look at them again. So for distance, d equals the square root x2 minus x1 squared plus y2 minus y1 squared. The formula for distance. Distance between any 2 points. Midpoint formula. Midpoint equals x1 plus x2 divided by 2. The order in which those x's is doesn't matter because you're adding them together. y1 plus y2 divided by 2. And midpoint obviously is going to be a point. Okay, so your solution is a specific point. It has an x value, it has a y value. You can think of this as the average, the midpoint as the average, the middle. Distance, on the other hand, is going to be a specific number because the distance between two things is going to be marked by the number of miles or feet or kilometers. So what we're going to do is let's first just practice finding a midpoint. So let's say the midpoint between the following 2 points, -5, 1 and -1, 6. You can always graph these to find the midpoint. It's not the easiest way. The algebraic way is going to be the easiest. So using this midpoint formula, I'm going to label these as x1, y1, x2, y2. And so we're plugging that into the midpoint formula here. So -5 plus -1 divided by 2, and 1 plus 6 divided by 2. For some reason the pen is acting up. -5 plus -1 is -6, divided by 2 would be a -3. 1 plus 6 is 7, 7 divided by 2 is 7/2. And so again, our result is a point, a physical point. If we were to graph all these, they would go along a straight line, and -3, 7/2 would be at the middle. It'd be the midpoint. In order to use distance, let's say we're given a triangle, not drawn to scale. And we're given the points, make this a little larger. Given the points A, B, C, and A is 4, 6, B is 7, 3, and C is 2, 1. And we're asked to classify the triangle as scalene, isosceles, or equilateral. And in order to do that, those classifications are based on the sides. And so I need to figure out what each of these sides equals. If all three of them end up being the same distance, that means all three sides are the same, so they're equilateral. If two of the sides are the same, the distance is the same, so then it's going to be an isosceles triangle. And if all three are different, then it must be a scaling triangle. And so I need to find the distance. So I'm going to say, okay, let's find the distance of x. So x is between a and c. So I'm going to plug that into my square root here. And so a, again, we can label these points. This is going to be x1, y1. This is x2, y2. Those labels are arbitrary. I could switch them around and it would be fine. A and C can switch which one is the first point. So this is 2 minus 4 squared plus 1 minus 6. The important thing is that you keep the order the same. So I went from C to A and then C to A again. Right? x2 minus x1, y2 minus y1. So x equals, we have the square root, 2 minus 4 is negative 2 squared is 4. 1 minus 6, negative 5 squared is 25. And so now I have x equals the square root of 29. And I'm just going to leave it as that, only because I think it'll be simpler to then compare the different sides. So we'll leave x as it is. Y is next. So let's find what y equals. Y equals the square root. Let's just leave a as x1 and y1, and I'm going to call b x2 and y2. So it's going to be 7 minus 4 squared plus 3 minus 6 squared. And so y equals 7 minus 4 is 3, 3 squared is 9, so the square root of 9, plus 3 minus 6 is 3, 3 squared is also 9. And so I get here that y is the square root of 18. And so I already know that one of these answers is not possible. It could not be equilateral. Not one of the possibilities, as all three sides have to be the same and two of them are already different. Now I don't know if it's scaling or isosceles, so I will have to continue and solve for z. Now, when I'm solving for z, again earlier I called c x2, y2, and I called b x2, y2. We're just going to change one of them. Let's change b. b is now x1, y1. Because again, the distance from b to c is the same as the distance from c to b, so it's not going to affect the outcome. So 2 minus 7 squared plus 1 minus 3 squared. Z equals the square root, so 2 minus 7 is 5, 5 squared is 25. 1 minus 3 is 2, 2 squared is 4. So here I get that z equals the square root of 29. That gives me that this triangle would classify as isosceles, as two of the sides are the same and the third is different. All right, again, this was a majority of review, things you had done before. The homework is going to be page 617, 4 through 12, even, 18 through 22, and 29 through 32. Please email your questions to me, and I will try to answer those as quickly as possible. This is again due, and I will have that in the lesson plans. Thank you.